Hello, everyone, and welcome to part 3 of our ISTQB Foundation Level V4 preparation journey. If you haven't seen the first two videos, I'll drop the links in the description, so make sure to check them out first. And now let's kick things off with the first question in today's video. Question number 21. A computer monitor has three interchangeable refresh rates: 60 Hz, 90 Hz, and 120 Hz. The refresh rate is governed by these rules. Switching from one refresh rate to another is instantaneous, meaning that it will go from 60 to 90 without passing on any refresh rate in between. The transistors are designed to run these three refresh rates only. Any other refresh rates will result in slow deterioration in the transistors and will eventually cause hardware failure. Now, what is the minimum number of values required to verify this monitor using BVA? As always, four options are provided, and they are 4, 6, 9, and 12. Pause now if you want to think about it. Alright, so let's try to solve this question together, but first let's rephrase the question to better understand it. So in our case, we have a computer monitor which accepts exactly three valid refresh rates: 60 Hz, 90 Hz, and 120 Hz. Any value outside these three refresh rates is considered invalid and could damage the hardware. That's good. Now, the correct choice here is option C, and let me tell you why. So basically, we must understand that in this exact instance, every refresh rate is a whole partition by itself. This is the key to knowing how to solve this question. So if we take a look at this sketch demonstrating the 90 Hz partition, we can see it contains one value, 90. And of course, the same can be applied to the other two partitions, I mean 60 Hz and 120 Hz. Now, in order to achieve 100% boundary value coverage, we don't just test the valid value itself, but also the values immediately around it, just below and just above. This gives us a way to check the boundaries of each valid partition. In other words, 60 Hz will require three values: 59, 60, and 61. The same will apply to 90 Hz with three values, and of course 120 Hz with the additional three values. So obviously 9 values are required, which makes option C the correct answer to this question. Let's see what we have next. Alright, the next question is number 22. Let's read it together. A course for IT fresh graduates require applicants to take a quiz to determine their knowledge base. Then they can be assigned to one of these classes. Advanced with 30% discount, this goes for unemployed students who pass the quiz. Advanced with no discount, and this goes for employed students who pass the quiz. Entry level with 30% discount, and this is for unemployed students who fail to pass the quiz. And lastly, entry level no discount, and this one is for employed students who fail to pass the quiz. Now, the structure of the quiz is 60 multiple choice questions. Each question is 1 mark, and to pass the exam, you must score 40 marks or higher. Then you're provided with these test cases. Test case 1, exam score 40, employed true. Test case 2, exam score 57, employed also true. And lastly, test case 3, exam score 29, employed false. The question says, what's the minimum number of additional test cases required to achieve 100% coverage of the only valid outcomes? As usual, four options are provided, and they are 1, 2, 3, and 4. Pause now if you want to think about it. So, were you able to get the correct answer? Well, it's option B. Two additional test cases are required to achieve 100% decision table coverage, and let's understand how. First, we must know that test case 1 and test case 2 are redundant. You see, both describe a case of a passing score, I mean 40 marks and above, and employed graduates. Thus, we can simplify our given decision table to just two test cases. Now, to figure out how many test cases remain for full coverage, we must draw the entire table of decisions. And obviously, we have four situations: past and employed, past and unemployed, then failed and employed, and finally failed and unemployed. And since we have two test cases covered, the remaining test cases are just two. Let's jump to the next question. Awesome. Question number 23. A video game controller operates according to the following state transition diagram. The initial state is standby. The game machine is awaiting for a card to be inserted. When an invalid card is inserted, the game will remain in this standby state. But when a valid card is inserted, the user will be transferred to the choose level state, where he can either cancel and return to the standby state or load the map and play the game. Now, once the game ends, the machine will initiate the print ticket state. And once printing process is complete, it returns to the standby state, ready to entertain another player. The question says, your manager provides you with the following test cases. And here you can see a nice table that contains three test cases, with each one having start state, input, and expected state. Now the question asks, what's the percentage of valid transition coverage these test cases provide? A, 25%, B, 33%, C, 50%, and lastly option D, 66%. Pause now if you want to think about it. Alright, let's try to solve this question. First, we must look at the state transition diagram and count the transitions simply by counting the number of arrows. We can see that there are 6 distinct transitions in total. See, 1, 2, 3, 4, 5, and 6. That means to reach 100% transition coverage, we need at least one test case per transition. So, 6 test cases in total. Now, let's inspect the 3 test cases provided by our nice manager. If you look closely, you'll find something suspicious. Test case 2 is invalid because it tries to go directly from play game to stand by without passing through print tickets. And that transition does not exist in the diagram. So test case 2 does not exercise any valid transition. That leaves us with only 2 valid test cases that actually cover our transitions. And since we already know that we need 6 test cases to achieve full coverage, we can do our calculations and divide 2 by 6, which yields 33%. Super! This makes option B the correct choice for answering this question. Let's move to question number 24. So, question number 24 says, you have a code block that needs to be tested. The code has 5 statements, and there are 4 test cases ready at the moment. Now, these test cases cover only the first 4 statements, and the 5th statement has no test case yet to cover it. You ran these test cases, and 3 of them passed and 1 failed. What is the percentage of statement coverage for this code block? And the options are 40%, 50%, 60%, and 80%. Pause now if you want to think about it. All right, so here's the trick. Many people get stuck deciding whether the answer should be 3 out of 5 or 4 out of 5. And in my humble opinion, the disagreement usually comes from the failed test case. Some might think, well, it failed, so maybe it doesn't count. But here's the key. Statement coverage measures whether a statement is executed, not whether the test case passed or failed. So, if a test case runs and executes a statement, that statement is covered, even if the test fails because of a defect. You see, once the defect is fixed, running the same test case again will simply pass, right? So, in our case, the four test cases together will cover 4 out of 5 code statements. One statement, the fifth one, is never executed by any test, so it remains uncovered. That gives us 4 covered statements divided by 5 total statements, which equals 80% statement coverage. Hope it was clear. Awesome. Now, I believe we are almost halfway through this video, and I think it's also a great time to remind you to check the links in the first comment. The exam course, including 6 additional exams, the training course, including a complete V4 explanation, quizzes, and more 3 exams, or the 2 courses in a bundle. So, if you want more practice, go for it. Now, let's get back to our current exam preparation and let's read question number 25 together. The question says, which of the following is an example of a drawback of the branch testing technique? A. Poor software implementation will result in poor branch testing and less defect detection. B. High cost due to the need to implement statement testing alongside branch testing. C. Branch testing usage is limited to only code coverage. And lastly, option D. Branch testing works great with dynamic testing but lacks compatibility with static testing. Pause now if you want to think about it. Alright, seems like an easy one. So let's analyze each option, see which of them resembles a drawback of branch testing. Starting with option A, and yes, this is one of the drawbacks of the branch testing technique. You see, the test itself depends on how accurately requirements are implemented in code. Any omission, misimplementation, or poor understanding of the requirements may result in branch testing not being able to detect possible defects. And that makes option A very good contender to be the correct answer. Now, let's quickly verify the remaining options. So, option B is obviously not correct. You actually don't need to spend extra budget on implementing statement testing if you have already implemented branch testing. If you remember, 100% branch coverage means 100% statement coverage. Now, moving to option C, and I believe this one is not correct because branch testing can be used for other non code work products like pseudocode and control flow charts. Lastly, option D is, of course, not correct. Branch testing can also be used in static testing to detect broken code links or unreachable code. Plus, branch testing can be used statically in code dry runs and workflow inspections. So, I believe it's very safe to put our confidence in option A as the correct choice for such a question. No doubt about that. Let's see what we have next. Alright, so the next question is number 26 and it says, a tester is making a list of possible defects he might encounter while testing a pre-release version of a mobile calendar application. The list items are based on the tester's experience from previous projects he worked on, such as trying to write letters in the date field or leaving the title of the entry blank and trying to save the entry. What is the testing technique the tester is about to perform? A. Statement testing. B. Checklist based testing. C. Error guessing testing. And lastly, option D. Decision table testing. Pause now if you want to think about it. All right, so I hope you didn't choose option B. This is not an example of checklist based testing. In fact, this is a pure example of fault attack, which in turn is a form of error guessing test technique. Let me summarize how the syllabus described the fault attack technique. Error guessing is a test technique used to anticipate the occurrence of errors, defects, and failures based on the tester's knowledge. Generally, the tester looks for issues related to inputs, outputs, logic, computation, interfaces, or data. Now, fault attacks are a way to implement error guessing. This test technique requires the testers to create or acquire a list of possible issues and design tests that will identify them. So, this question is a very classic representation of the fault attack technique. But if you're wondering why this isn't an example of checklist based testing, I would say that in checklist based testing, the checklist items are usually phrased in the form of questions and often derived from standards, requirements, or regulatory guidelines. So, if you feel confused between the two, you can refer to the following two topics: error guessing, this one, number 4.4.1, and checklist based testing, number 4.4.3. Now, let's move to the next question. All right, so the next question to encounter is number 27, and it says, you are in a job interview for a software tester position. The interviewer gives you a mobile device with a beta version of an app already installed. Along with that, he also hands you this exact sheet of paper. What is the best test technique to be used in this situation? A. Exploratory technique. B. Decision table technique. C. Error guessing technique. And lastly, option D. Checklist based technique. Pause now if you want to think about it. All right, so let's analyze this specific context. It seems that the interviewer is trying to know the level of experience of the applicant tester. The app is in a beta version, so a lot of issues are expected to be found, and the time frame is 30 minutes, so basically the applicant is time pressured. Now, what about the app itself? There's no provided requirements, user stories, or acceptance criteria to work with. However, we can understand what this app is all about from its name, Gemless Fit. An app to help the end user to get fit without gym equipments, maybe like home exercises or something similar. So, it makes sense to use exploratory testing in this exact situation. Time pressure and the lack of information about the test object advocate the usage of this test technique. Furthermore, the provided piece of paper looks like a minimized test charter, and we all know that one primary use of test charters is in exploratory testing. So, option A is the correct answer to this question. And now let's move to the subsequent question, number 28. So, question 28 says, the I in the INVEST principle of user story stands for independent. Which of the following statements best represents the word independent? A. A user story is to be written independently. So, the tester writes it without referring to other stakeholders' point of view. B. a user story should be independent of the product requirements, and it should be usable across different products and projects. C. A user story should be independent from other user stories. The developer and testers can pick any user story and start implementing or testing directly. And lastly, option D, the letter I does not refer to the word independent anyway. Pause now if you want to think about it. Great. Let's analyze each option independently. So, option A states that independence means writing the user story without referring to other stakeholders' point of view. I would say this is criminally misleading. User stories are meant to capture stakeholders' priceless perspectives. So, independence doesn't mean ignoring stakeholders or their needs. Now, when looking at option B, we can see that it's not correct because it suggests a story should be independent of product requirements, and not only that, but also reusable across different products and projects, which makes no sense at all. User stories must tie back to product specific requirements and deliver clear business value, not be generic, not be one size fits all artifacts. Next, let's take a look at option C, and I would say this one seems like a very good choice. It correctly reflects the intended meaning. A user story should be self contained and not tightly coupled to other user story. This ensures it can be implemented and tested independently. And this reduces sequences constraints, reduces dependencies, allows parallel work, and simplifies the planning process. And finally, option D is without a doubt incorrect. The I in the invest indeed stands for independent. So, yeah, option C seems like the best choice available, and indeed is the correct answer to this question. Now, let's move to the next one. All right, folks, let's take a look at question number 29, which seems like a long one. Consider the following three steps in a development process following ATDD model. Step 1, user story writing and the acceptance criteria. Here's the user story. As a premium YouTube user, I want to be able to download videos on my smartphone so that I can watch them offline if I don't have an internet connection. And here's the acceptance criteria. 1. The user can download videos when they have an internet connection. 2. The user can see a pop-up message showing the download progress. 3. The user can enter their premium library and see a list of downloaded videos. And 4. The user can play downloaded videos when there is no internet connection. Now for step number 2, test case writing. So basically, we have two test cases. Test case 1, test steps, open YouTube, select any video, and choose download. Test case 2, test steps, open YouTube, and open the user's library. Now for step 3, developers will start implementing. Now, the question asks which of the following options mostly represents an issue with this setup. A. The user story is lacking the goal to be accomplished. B. The acceptance criteria is not in the given when then format. C. The test cases do not cover the acceptance criteria. And lastly, option D. The code implementation step should come before writing test cases. Pause the video now if you want to think about it. That's great. Let's discuss each option together. Starting with option A, we can easily say it's not the option we're looking for, as the goal to be accomplished is fulfilled. In this case, the goal to be accomplished is the statement, I want to download videos on my smartphone. Now for option B, We can also say it's not the answer we're looking for. This is because acceptance criteria can be written in the format of given when then, or bullets, or any other format agreed upon by the team. Now, when looking at option C, we can confirm that the test cases do not fully cover the acceptance criteria. You see, there should be an additional test case that covers the ability to play the downloaded videos when the user's device has no internet connection. So, I believe option C is a very strong contender to be the correct choice for this question. Lastly, option D is obviously not correct. Nothing out of the order here. As in acceptance test driven development or ATDD, the code implementation normally comes after writing test cases. So, based on our simple analysis, I believe we can all agree that option C is the only suspicious one that represents a problem with such a setup. That's awesome. And now we can move to question number 30, which is the last one in this video. Well done, everyone. So, question number 30 says consider the following testing tasks: 1. User stories risk analysis, 2. Define product backlog, 3. Determining the test approach, 4. Estimating testing effort for testing tasks, number 5. Identify functional and non functional testing, and lastly, writing user stories and acceptance criteria. That's number 6. Which of them relates to release planning and which relates to iteration planning? Take a look at the options, pause for a while, and try to pick the correct choice. All right, so this question is not about analysis, not about context awareness, and surely no tricks are involved. This question is 100% dependent on you to remember which of the mentioned tasks are related to release planning and which are related to iteration planning. And basically, option A is the correct one here. Let's refresh your memory. So, defining product backlog, determining the test approach, and writing user stories and acceptance criteria are all related to release planning. On the other hand, iteration planning includes tasks such as user stories risk analysis, estimating testing effort for testing tasks, and identifying functional and non functional testing. All right, folks, we've made it. The next stop is gonna be the last one in our journey, where we will encounter the last 10 questions in our ISTQB Foundation Level V4 preparation journey. Thank you very much for watching. Don't forget to subscribe to our channel, and I'll see you in the next video. Have a great day, everyone. Goodbye.